Hi, I'm Benovator, and I'm going to show you how to measure the on-state resistance, or the RDS on, of a Mosfet. Now, this is a very standard Mosfet. This is the 3205 Mosfet. This is a very cheap, it's about 25 cents for this Mosfet, and yet it is capable of handling about 75 amps at 55 volts. So very, very, very powerful, and fast switching speed, basically standard stuff. Now, we know from its data sheet that this one has a on-state resistance of 8 milliohms. 8 milliohms. Now this one, we don't know it. We don't know what the on-state resistance of that MOSFET is. So the way we can test that is this multimeter reads the voltage across the MOSFET, the voltage across its source and drain, and by the way, the middle pin is actually, if you can see it there, the middle pin is missing on this particular MOSFET. On this one, all three of them are there. On that one, the middle one is missing. That's because you can actually use the case, this one with the hole in it, as the middle pin. So it's just easier to use that as the middle pin instead of using the middle pin. So we just cut off the middle pin. So we use this multimeter to read the voltage across it. Right now, it's off. Right now, the MOSFET is off. So the voltage across it is whatever our supply voltage is. Now, the things you need for this are a 12 volt source, a 12 volt source of current, which right there it's a PC power supply, a load, a dummy load, and what we're using here is just a microwave oven transformer. Need two different multimeters and just everything, all the hookups you need, and a 9-volt battery. That's to turn the MOSFET on. Right now, it's off. When I take this yellow alligator clip and attach it to the positive of the battery, it will turn it on. So, what we do is we take the power from this, which we just have it rigged up ghetto. The yellow wire is the positive 12 volts, and the black wire is ground. The ground comes through this wire, through the multimeter, right here, through this multimeter. This one reads current, this one reads voltage across the MOSFET. And then it goes through this wire and attaches right there to the source of the MOSFET. Now the positive, on the other hand, hooks up directly to this power cable, and the power cable is just hooked up directly to the transformer. Now the only thing attached to the gate of the MOSFET is the yellow wire, and what's attached to the source are a power lead from our amperage multimeter right there, and the other one, this white one, hooks up to the negative of the battery. And everything that's hooked up to the drain of the MOSFET, or the positive side of the MOSFET, is of course this cable and the positive lead from the voltage multimeter. Now right now it's turned off. As you can see there are 0 amps of current flowing through it, so the voltage across it is 12, which is the same as our supply voltage. Now, one thing to note about this experiment is that, see that black wire? The black wire just below the yellow one. That one has to be on the farther side. It cannot be in between where the current is coming from. So it has to be hooked up on the farthest end of the source pin. If it's hooked up between where the current is flowing, you'll get an inaccurate reading. It'll say the on-state resistance is way more than it actually is. So it's very important that that lead not be in between the power source. So hook up where the current flows through. It comes from this red cable here. Hook that up as close as you can. So, right now, it's off, but we'll turn it on by touching this yellow one to the positive. And then, what we do is we take whatever this voltage is in millivolts and this one in current, which is in amps, and we take this number and we divide it by this one, and that gives us the on-state resistance in milliohms. So right now it's on, and its on-state resistance is 6, or the voltage drop across it is 6.7, and the current is 7.83 amps. Now if we take this number in millivolts and this number in amps, divide this one by this one, there we go, turned it back off. If we divide that number by that number, I'll turn it back on, but I can't keep it on indefinitely because the power wires from this cheap multimeter, they'll heat up. If we take this number and divide it by this one, we get an on-state resistance of 0.85 milliohms, not ohms, milliohms. There we go, we'll turn it back off. So this one, this MOSFET, the 3205, has an on-state resistance of 8 milliohms, and that one right there has an on-state resistance, we measured it, of 0.85 milliohms. That means that this MOSFET here is about 10 times as powerful as this one. Now, God, I hate that multimeter. So, this MOSFET we know is the 3205. This one is actually a much newer and much more expensive, unfortunately, MOSFET. That MOSFET is the IRF B7430. That MOSFET right there is capable of handling way more current and has a much lower on-state resistance. Its maximum on-state resistance is 1.3 milliohms, which means that that MOSFET is capable of handling 195 amps. That little thing right there, 195 amps, is capable of flowing through it. This one is actually only capable of 75 amps, which is still relatively a lot. But think about that, almost 200 amps flowing through something that's about the size of your thumbnail. That's very impressive, and this has a ton of applications which I hope to take advantage of. Now, we measured its on-state resistance of being... Thanks. We measured its on-state resistance of being 0.85, but that's probably just because it's cold and we're not sending much current through it. Also, it may be a measurement error, but I doubt it. So yeah, that's definitely within that's definitely probably relatively correct. That's actually a little bit lower than what the data sheet says. So very impressive MOSFET, and that is how you do it. You measure the voltage across the rightmost pin and the base. It's not the base, it's the drain. So you measure the voltage across those two and send a known current through it, and you divide the voltage drop in millivolts by the amperage, and that will give you the on-state resistance in milliohms. I hope this video helped you. I hope it was brief enough. I really tried, and I'm sorry about the production quality. Peace.